Bismillahirrahmanirrahim. So we were talking about bounded sets. What is meant by bounded above and what is meant by bounded below. Is my sound clear?
Yes, sir.
Yes.
Okay. So we have an important point here to note down that when a set is bounded and when a set is finite. These two examples are there where the two sets are bounded, but they are infinite. We can have examples of bounded sets that are finite. That means we have only a finite number of elements in that. So finite set or infinite set is based on how many elements are there. If there are finite number of elements, the set is finite set. But if the number of elements in the set is infinite, only then it is infinite set. But that infinite set can be bounded. So by the definition of upper bound, an upper bound is any number which is greater than or equal to every element of the set. So if it is strictly greater than, then even then it is an upper bound. इसका मतलब ये जो सेट दो एग्जांपल लिखी हुई है आपके सामने, दोनों में 3 अपर बाउंड है, मगर 4 भी अपर बाउंड है, 5 भी अपर बाउंड है, 3 से बड़ा कोई भी नंबर अपर बाउंड है. So we'll come to that point again. Here we note that we can define greatest element of the set if every element of the set is less than that. Rather, it should not be strictly less than that, less than or equal to. Because here, if you think in this set, what's the greatest element of the set? Can anybody comment?
3.99999 something.
2.99999 कहना चाहिए तुम्हें, है ना?
My bad. Yes.
मगर क्या तो जी.
सर कुछ स्टूडेंट्स वेट कर रहे हैं, आप उन्हें अंदर आने दें मीटिंग में.
भैया जितने भी आ रहे हैं नजर आ रहे हैं मुझे, मैं फौरन एडमिट कर लेता हूँ.
ओके सर, हाँ हो गया.
So in this set, somebody was trying to say that the largest element or the greatest element is 2.999999, but I cannot tell exactly what's the greatest element. But a greatest element will be an element which is the element of the set and greater than every other element of the set. Similarly, smallest number element of the set. And again, I should have for smallest. Small g is the smallest element of the set. It has to be equal to some element of the set, and all the rest of the element of the set should be greater than that. So again here, I cannot tell what is the smallest element of the set. But in this case, we can say that 3 is the largest element or the greatest element and 2 is the smallest element. Oh, the greatest copy हो गया यहाँ पे. So we are introducing terms bound, upper bound, lower bound, greatest element of the set, smallest element of the set. And in the same, we then introduce the definition of supremum and infimum. Uh, by design, if a set is bounded above, it can have many upper bounds, and smallest of those upper bounds is the least upper bound, or the supremum, and you can also say that the greatest element. If a set is bounded below, then uh, it can have many lower bounds, and the greatest of them should be called greatest lower bound. There are terms used as brief terms. Uh, least upper bound के लिए LUB and greatest lower bound के लिए GLB. But in this course, mostly we will be using the term supremum and infimum of the set. Now, going back to these examples, 2 is the infimum in this set, 3 is the supremum in this set. In this set, again, 2 is the infimum and 3 is the supremum. So there is a difference between greatest element and the supremum. We can always tell, oh, there is a condition, but there we can always tell supremum of the set, but greatest element of the set may not always be clearly defined, or you cannot explicitly say what's the greatest element here. But 3 is definitely the smallest of the upper bounds, that is supremum. Similarly, you cannot say what's the smallest element of the set, this set, but we can clearly say that this is the largest of the lower bounds, and 2 is the infimum. And we note about these things. If M is the supremum of a set, then for every element of the set has to be less than or equal to M. No number less than this supremum can be an upper bound of the set. That is for any small number epsilon, kitna bhi small ho. If you write down M minus epsilon, this has to be less than at least one element of the set. Similarly, there must exist an element Y that has to be greater than M minus epsilon. And if supremum smallest upper bound है, उससे छोटा कोई भी number लोगे, that will not be an upper bound. Now, if small m is the infimum of the set, then for all x of the set, element of the set, they have to be greater than or equal to small m, which is the infimum. लेकिन अगर तुमने infimum में छोटा सा नंबर भी ऐड कर दिया, तो अब वो लोअर बाउंड नहीं रह सकता, और सेट का कोई ना कोई एलिमेंट जो है इससे छोटा होना चाहिए, m plus epsilon. I can again use that drawing board. Now, if I'm talking about this line, somewhere here is the infimum, somewhere here is the supremum. If you consider m minus epsilon, that has to be somewhere here, very, very close to m, But since m is the supremum, सेट का कोई ना कोई एलिमेंट m माइनस एप्सिलॉन और m के दरमियान होगा. That is what we are saying, trying to say. इसी तरह अगर m plus epsilon some point here, so m is the infimum. Every well element of the set is greater than or equal to this small m. जैसे ही तुमने m में कुछ छोटा सा small m में यानी infimum में कुछ ऐड किया, this has to be a number such that between small m and m plus epsilon there has to be some elements in the in this small gap. So m plus epsilon has to be less than some element of the set, and m capital M minus epsilon has to be less than some element of the set. This is what is being said here. Going back to the worksheet, in these notes, whatever I've just demonstrated in the picture, these 3-4 points are describing that. Now, can a set have two supremum? अभी जो बात की है हमने उसी को सामने रखें, तो it is not possible that there are two suprema or two minimum. इस सवाल के जवाब में what we are trying to state is that we on contrary assume that there are two distinct real numbers m1 and m2, both are suprema of set S. Every supremum of a set has to be an upper bound of the set as well. If m1 is supremum, then it is an upper bound of S. If m2 is a supremum, so m2 is also an upper bound. But if m2 is supremum, it has to be greater than m1. If m1 is a supremum, then it has to be greater than m2, and that simply means that they cannot be distinct, they have to be same. In short, whenever we have any bounded set, it will have a unique supremum, a unique minimum, infimum, unique least upper bound, and unique greatest lower bound. Look at these examples. What about set of natural numbers? First, my question is this set of natural numbers finite? जी जनाब. Set of natural numbers is finite or infinite?
Infinite.
Infinite.
Because there are infinite natural numbers 1, 2, 3, 4, 5, 6. They are not continuously placed on the line, but they are infinite. What about the integers?
Infinite.
Infinite.
Okay.
Infinite.
Coming back to natural numbers, is the set of natural numbers bounded above?
No.
No.
Because I mean to ask, can you find a finite number so that every natural number is less than that? So it is not
No.
possible. So is it bounded below?
No.
Yes.
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 It starts at 1.
1.
So 1 is the greatest lower bound, and any number less than 1 is a lower bound. What about integers? आपने कहा infinite set है. Is the set of
No.
integers bounded above?
No.
No.
Bounded below?
No.
Yes.
No.
So, no, it is
No.
not. So set of integers is unbounded. What about set of rational numbers?
Unbounded.
Unbounded. Set of real numbers?
Unbounded.
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 What about any finite set of numbers?
Bounded. Both sides.
Every finite set of numbers, जिसमें number of elements जो हैं वो finite हैं. You can count them.
Bonded.
and the
Bounded.
count is finite, so it has to be bounded. अगर मेरे set में 4 elements है 1 2 3 4, it is bounded because it is both bounded above and bounded below. What about this set?
This is a natural number set.
They are all positive real numbers. This is a set of all positive real numbers. Bounded above है?
No.
No.
Bounded below है?
Yes.
Yes.
What's the greatest lower bound?
0.
1.
1.
Zero.
Zero.
Zero. Zero.
Zero.
Sir, why 0?
Because every element of the set is greater than 0. You cannot tell me the smallest element of the set. But
Okay.
zero जो है, every real number which is greater than 0 is element of the set. So 0 is not only a lower bound, but it is the greatest lower bound. -1 be lower bound, and -2 be lower bound, etc. What about this
All
set?
right.
The next one.
Bounded.
It is bounded.
Bounded.
What's the supremum?
4.
Infimum?
0.
0.
Greatest element?
3.999.
3.999.
Ah,
Yeah.
999 mat kiya karo. We cannot tell what's the largest element. What's the smallest element?
You cannot tell.
We cannot
That's
tell.
it. That is it. What about this set?
0 infimum, 1 supremum, and 1
Bounded
Largest element 2.
largest element
1.
and smallest
1.
element.
0.
So supremum is 1, infimum is 0. Is it finite or infinite?
Finite.
Eh?
Finite.
Infinite.
Fine.
Infinite.
X is
Infinite.
any rational number. 0 से 1 के दरमियान कितने rational number होंगे? मैं नहीं बता
Infinite.
सकता.
हाँ,
Infinite.
बहुत सारे हो संगे.
Ah. Now this set constructed from the set of natural numbers. 1 upon 1, 1 upon 2, 1 upon 3, 1 upon 4, etc.
Unbounded.
So we
जी
cannot tell about supremum.
अच्छा
Infimum तो 1 हो जाएगा. 1/1.
देखो बात
शायद.
infimum नहीं है वो 1 1 upon 2 1 upon 3 1 upon 4 1 upon as I increase n, what's the size of element of this set? Becoming
Infinite.
larger or smaller?
Smaller.
Smaller.
किस नंबर से छोटे नहीं होंगे इसके एलिमेंट्स?
0 से छोटे.
0 से छोटे नहीं होंगे. तो फिर लोअर बाउंड क्या हुआ? Infimum क्या हुआ? 0 is the infimum
0.
and 1 is the supremum. Okay? And what about this one? जी जनाब. What will be the first element of this set?
-1.
Plus 1 is
Minus
infimum
1.
होगा.
Then plus 1 by 2. Then
Minus-
minus 1 upon 3. Then plus 1 upon 4. Then minus 1 upon 5. Then positive. Then
1 upon
negative. Then positive. Then negative. Now start thinking कि कौन सा right पे आ रहा है, कौन सा left पे आ रहा है. Leftmost कौन सा हुआ?
-1.
-1 leftmost हुआ. Rightmost कौन सा हुआ?
Half.
Half. So all numbers here this time are between -1 and 1 by 2. On the left side -1, on the right side 1/2. तो सुप्रीमम 1/2 हो गया और इन्फीमम -1 हो गया. इसको मैं यहाँ से निकाल देता हूँ. इसमें मुझे साइन लगाना पड़ेगा. Anyways, when you plot these points on the real line, one appears -1, then other appears 0, then -1/2, -1/3, then +1/4, then -1/5. तो 0 की तरफ तो आ रहे हैं ये, लेकिन they all these numbers, all the elements of this set are lying between -1 and 1/2. So -1 is an infimum and 1/2 is a supremum. What is the smallest element of this set?
Which one is sir asking?
What is the smallest element of this set?
-1.
Yes.
-1.
The largest?
Half.
Half.
That's good. अब इस अगले सेट के बारे में खुद सोच लेना. अच्छा,
0, 3.
और सोचना कैसे है? हर एलिमेंट लिखोगे, हर एलिमेंट को लाइन पे ड्रॉ करोगे और फिर फैसला करोगे. और अगर ड्रॉ किए बगैर फैसला करने की सलाहियत पैदा हो गई है तो वाह वाह. Now we can come to the last and one of the most important properties of the set of real numbers, the completeness property. This property is possessed by the set of real numbers, but not by the set of rational numbers. However, both are ordered fields. Now, what is the completeness property? Completeness property says that every I make it bold, every non-empty set, subset of the set of real numbers, which is bounded above, has a supremum in the set of real numbers. जब भी ये सेट ऑफ रियल नंबर्स का कोई सबसेट बाउंडेड अबव होगा तो उसका सुप्रीमम या लीस्ट अपर बाउंड जो है वो सेट ऑफ रियल नंबर्स में ही होगा. जब तक काउंटर एग्जांपल सामने आएगी बात भी तो समझ में नहीं आएगी. लेकिन अल्टरनेट स्टेटमेंट ये है कि एनी सेट व्हिच इज बाउंडेड बिलो a subset of real numbers which is bounded below must have an infimum which is in the set of real numbers. This is the completeness property. This property is not possessed by the set of हमने अभी कहा rational numbers. So the completeness, this completes the description of the set of real numbers R that has an algebraic structure. It has order. It is field. It is ordered field. It is also complete. It has already been stated that the set of rational numbers as well as set of irrational numbers are not complete. It is so simply because if we consider any bounded set of subset of rational numbers, the supremum and infimum of the subset may not be an element of the set of rational numbers. Look at this example. मैंने कहा जब तक counter example तुम्हारे सामने नहीं आएगी उस वक्त तक बात समझ में नहीं आएगी. We have discussed some examples of sets and now this set is defined in what way? इसके elements ऐसे हैं कि जिनके square जो है that remains less than 2. Now this is a subset and every element of this set is a rational number. So this is a subset of rational numbers. Its supremum, now x square less than 2 का मतलब है अब numbers minus square root 2 और plus square root 2 के बीच में है. So if you think about the supremum, square root 2 है, लेकिन square root 2 rational numbers के element नहीं है. इसका मतलब है कि ऊपर जो completeness property बताई गई है कि if a set is bounded above, then in the larger set in our universe, here the universe is Q. If a subset of Q is bounded above, its supremum for completeness should be in Q, but square root 2, which is the supremum of this set, is not in Q. Get this point?
Yes, sir.
Yes, sir.
Similarly, minus square root 2 is the infimum of this set, but that doesn't belong to the set of rational numbers. Hence, the set of rational numbers is not complete. So, completeness property is typical to the set of real numbers, not possessed by the set of rational numbers, not possessed by the irrational numbers. मैं इसी तरह एक सेट डिफाइन कर सकता हूं कि all elements belonging to irrational numbers that lie between 1 and 2. Okay. Now here is a set of irrational numbers that lie between all irrational numbers that lie between 1 and 2. The set is bounded. The supremum is 2. The infimum is 1. Neither the supremum nor the infimum is an irrational number. They are rational numbers. So supremum is not in the set of irrational numbers. So irrational number is not set of irrational numbers is not complete. The completeness property is based on the fact that अगर कोई सबसेट लें आप किसी लार्जर सेट का और उस सबसेट का सुप्रीमम लार्जर सेट में जरूर हो तो वो लार्जर सेट कंप्लीट होता, लेकिन अगर सुप्रीमम या इन्फीमम लार्जर सेट में नहीं है तो वो लार्जर सेट कंप्लीट नहीं है. तो आर जी कुछ कह रहा है
सर, इसमें वन साइड कंप्लीटनेस आ सकती है, लाइक फॉर एग्जांपल वन साइड कंप्लीटनेस का कांसेप्ट तो यूज नहीं होगा ना
किसी एक तरह, जैसे फॉर एग्जांपल मैं यहाँ पे इस नंबर को अंडर द रूट डाल दूं, मेरा ख्याल है आप ये सजेस्ट कर रहे थे. ये बाउंडेड अबव है, इसका सुप्रीमम इरेशनल है, बट इट्स नॉट ओनली सुप्रीमम बट its infimum should also be in the set of irrational numbers. So both sides होना चाहिए. ठीक है, completeness on one side नहीं है. When we have written the completeness property, तो हमने यहाँ से लेके यहाँ तक बोल्ड किया था. That means completeness is from both sides. बाउंडेड अबव हुआ तो सुप्रीमम आर में होना चाहिए, बाउंडेड बिलो है तो सुप्रीमम इन्फीमम आर में होना चाहिए. हाँ, एक चीज हो सकती है कि मैं इस एग्जाम्पल को जरा बिगाड़ दूं सिर्फ टू कंफ्यूज यू. कंफ्यूजन्स ब्रिंग आउट मोर आइडियाज. जी जनाब, अब क्या कहते हैं? बाउंडेड अबव है और सुप्रीमम इरेशनल है. ऑल राइट. इज इट बाउंडेड बिलो?
नो सर.
जब बाउंडेड बिलो ही नहीं है तो अब मैं इन्फीमम की बात ही नहीं करूंगा. ओके, सो दैट विल स्टिल बी द सेम सिचुएशन. याद रहना चाहिए, मोटी बात जो याद रहने की वो ये कि ये प्रॉपर्टी सेट ऑफ रियल नंबर्स में तो मौजूद है. बाउंडेड सेट, अगर आर का एक सबसेट बाउंडेड है तो सुप्रीमम और इन्फीमम दोनों उसके आर में होंगे. अगर रैशनल नंबर्स का एक सबसेट बाउंडेड है तो उसके सुप्रीमम और इन्फीमम उनमें से कोई एक या दोनों हो सकता है क्यू में ना हो. आप बाय कंस्ट्रक्शन ऐसे सेट बना लीजिए कि सुप्रीमम और इन्फीमम दोनों जो हैं वो क्यू में हैं, मगर वो एक एग्जाम्पल तो सेटिस्फाई करेगी, लेकिन इन जनरल क्यू में ये प्रॉपर्टी नहीं है कि इन जनरल क्यू का कोई सबसेट जो है, जैसे कि हमने एग्जाम्पल दिया, एक एग्जाम्पल काउंटर मिल जाती ना तो फिर हम उसको रूल नहीं कहते. वी कैनॉट फाइंड अ काउंटर एग्जाम्पल as we have written here for rational numbers. रियल नंबर्स के लिए कोई काउंटर एग्जाम्पल ऐसी नहीं आ सकती कि आप एक बाउंडेड सेट लें, सबसेट आर का, और उसके सुप्रीमम और इन्फीमम जो है वो सेट ऑफ रियल नंबर्स में ना हो. जबकि यहाँ रैशनल नंबर्स में और इरेशनल नंबर्स में कई एग्जाम्पल्स बनाई जा सकती हैं जो बाउंडेड होने के बावजूद जिनके सुप्रीमम और इन्फीमम या उनमें से कोई एक जो है वो सेट में ना हो, क्यू या क्यू प्राइम में ना हो. तो that said about the completeness property, and I think I stop now. This is the last topic of the first chapter that I have to discuss, Archimedean property or Archimedean property. I'll discuss this property next time, and I'll terminate my discussion at this point. If you have any question, you can ask. Otherwise, मैं इस मॉडिफाइड हो गई है फाइल, तो इसको मैं दोबारा रिसोर्सेज में डाल दूंगा LMS पे, और होपफुली फेसबुक पे भी शेयर कर दूंगा. तो इसको पढ़िए, मज़ीद एग्जांपल्स और क्वेश्चंस में बना के दूंगा होपफुली आज या कल. तो उन सवालों पर गौर कीजिएगा. और अब नॉट नेक्स्ट लेक्चर बट नेक्स्ट वीक से तैयार हो जाइए असाइनमेंट्स और क्विज़ेस के लिए. कैसे कंडक्ट होंगे वो पॉलिसी में अनाउंस कर दूंगा. ओके.
Okay.
Okay, sir.
Okay, then I terminate this session. First, I stop recording.